I'm Rhea.
I'm Juan Pablo.
And I'm Gabby.
And we're
Teens Tutor Teens.
Hey guys, welcome back to another Teens Tutor Teen. And I'm Gabby, and we're going to be going over root, addition, and subtraction. Okay, so you may be like wondering what is with these roots. So a root can look anything kind of like this. And that's basically telling you, let's put an X on it here. So that's basically telling you that any number or variable or something underneath this root is actually being exponent, like it's being to the power of 1/2 in this case. Now, if you can also have a root, and the thing under here is the radicand underneath the root, and that could be exponentiated even to 1/3. Now, as you can see, the same number that was underneath here was also underneath here. And I'll give you guys some roots on the basis and stuff, and it goes on and on and on, even down to where we start to get into n, in which n stands for a kind of a sense all real numbers, so all real. And that kind of turns into x to the 1 over n. So now let's get into some examples on, now that you guys have a refresher course, examples on how you can add and subtract roots. So let's start with a simple example. Let's start with the basics here. The square root of 1 plus the square root of 1. Okay. So ideally what we're thinking about when we're doing this, we're thinking about a 1 in front of each root. Because ideally we know that 1 times square root of 1 just equals square root of 1. So, going back here, we're asked to find what that equals. What you would do then is you would take the two numbers in front of the root and in a sense compose them right in front of the root. And understand, this can only apply to when the roots have the same roots of each other. You can only add when the roots are the same magnitude, same number of each other. And you're going to end up with an answer of 2 square root of 1. Funny thing we also know is that we also know that the square root of 1 equals 1. So that just turns out to be 2. Now let's solve this in a different way. We're asked again, 1 square root of 1 plus the square root of 1 equals what? Okay, so we also know that it also equals 1 plus 1, because we can find out by this rule that the square root of 1 translates to 1 plus the square root of 1, which translates to 1. That equals 2. So we just found out from example 1 and example 1b, they are actually both equal to 2. Now you may be asking, why does this make sense? Understand, you can only add when the roots are, in a sense, the same of each other. They have to be equivalent. You cannot add a root that is, in a sense, not equivalent. These numbers under the radicand, these magnitudes, they must be the same to add. And also subtract, but we'll get in there in a little bit. Okay, now let's go to a little bit more difficult example so you can actually test what you learn from this. Okay, let's try example 2. Square root of 3 plus the square root of 9. Okay, you may be thinking, well, and you're also asked what it equals. You may be thinking, well, how do I add these? You would first acknowledge that the square root of 3 cannot be broken up more. So you just do square root of 3. Plus, acknowledge that this also equals 3 squared. Now remember, if you do remember that what this radicand equals, we also remember that this can also be written as square root of 3 plus 3, 2 to the 1/2. That also equals square root of 3 plus 3 to the first power. And any number to the first power just equals itself. Okay? So then we finally also get the final answer of question mark, which just equals 3 plus square root of 3. Now what people commonly mistake is they try to say when you add something to that, it does not equal the same thing as this added with that. Does not. These two, not the same. They're not. And I'm going to go more into detail why this is so. We can also understand that when I told you guys previously, when I told you can only add roots of the same nature underneath, you can also write it as 3 root 1 plus root 3. And also figure out that these two, the roots of themselves, are not the same. Therefore, you can't add them. If that makes any sense, the reason why the question mark would just equal 3 plus the square root of 3. Now let's erase this. And let's do a different example where you could possibly add them. We're on example 3. Square root of 2 plus the square root of 8 equals what? Okay, now let's think about this. Square root of 2, I can't break it up anymore, so it's going to be square root of 2. Now the square root of 8 can be broken up as the square root of 2 to the third power. Or it can also be written as square root of 4 times 2, same thing. And what we can actually do is we can actually take this 4 out and translate this as 2 root 2. Maybe wondering, where did this come from? Well, since we know that square root of 8 also equals square root of 2 times 2 times 2, and we know that we can do square root of 2 squared times 2, and we also know that we can multiply across, in which we can do 2 squared to the 1/2 times 2 to the 1/2. We can therefore get an answer of, when multiplying these things across, 2 to the first power times the square root of 2. Therefore, we would get 2 square root of 2. So I'm going to plug this right here. Oops, that's not supposed to be a 3. Oops, 2 equals question mark. And remember how I also said you can add roots with the same base. So if that equals that, yes. So that's a yes to add. Therefore, you would take, like we said once again, we're imagining there's a 1 here. Take these two, put them together, and therefore multiply by that root, which equals question mark. Therefore, 3 square root of 2 equals question mark. Now that example required you also to know a little bit about how roots work with multiplication, which is going to foreshadow a little bit what the following next lessons are also about too. But we're going to stick with addition and subtraction in order for you guys to grasp the concept. So in this example, I'm actually going to let you guys think about it before I start to work on it. You actually can take time to pause the video. So let's do number 4. But now let's do 3 plus the square root of 27. If you need to take time, please take time and try to figure this out on your own. And, we'll go back to it. Okay, now that you're back, let's figure out what question mark equals. We're moving down here. 3 can't be broken up into any more than 3. So it's just going to be 3 right there. Now 27, let's think about this. What things just equal 27 in itself? We know that we could possibly do 3 times 3, which makes 9, times 3, which equals 27. And we also know that it can be broken up as 3 squared times 3, which we also know can be broken up as 3 squared to the 1/2 times 3 to the 1/2. We know when multiplying across from these two, we also get, now we get 3 to the 1st times 3 to the 1/2, which translates into 3 square root of 3. So we're going to add it right here, 3 square root of 3. And now we're just going to add across. Imagining that there's a 1 here. So that's going to leave us with 1 plus 3. Multiply the square root of 3. Because we know that the distributive property works in this case. And it's going to leave us with 4 square root of 3 equals question mark. Our final answer. I like that smiley face. Okay, now we're going to think about it more in subtraction terms. So instead of doing it this way, I'm going to show you actually, in a sense, I call my examples 4B. In a sense, now if we were to say square root of 3 minus square root of 27. Note that everything that we've done here stays the same. So it's actually going to end up to be square root of 3 minus 3 square root of 3. We're trying to find out what question mark equals. And you just think of it as the same concept that you did when you're adding, when it would be 1 minus 3 square root of 3. And that would actually equal, this case, negative 2 square root of 3 equals question mark. That's your final answer. So also understand that whenever you add and subtract, you tend always usually to get, it won't usually always be the same exact answer in terms of what things you would add and what things you would subtract from. So it'd be the same process though. The same way you broke down for 27 here, you'd break it down right here. And the same thing in how you would compose the function here, compose it here. Only thing that would probably be different is your answer, which we can confirm we got 2 different answers. A lot of the things here are the same in this case. So we're going to go look back again at probably 2 of the most common misconceptions that people make. So let's go over here. Common mistakes. Number 1, like we said, they assume that square root of n can be added to square root of m. So in this case where n does not equal m in terms of all real numbers. So people sometimes assume that they can do 2 and 3, and they think that also equals the square root of 5, which it does not. And sometimes people also usually think that they can simplify this answer, but this is usually as simplified as it gets. This is very simple, which is actually a good thing. You usually want to put your answers in the most simplified choice, because usually that's how it shows up in multiple choice, but this is actually very simplified, this answer right here. This is also simplified too, assuming I can't break things down even more and more. And the second misconception people think is they think they can't break down roots. So for example, like I was giving you guys previous examples where I'd say square root of 3, and the previous example actually square root of 27. They think that this is not. So this is not simple. What you want to do is you want to instead think about the terms and break it down where you can get your most simplified answer, and this would in turn, so this is simple. And you want your answers to be more in a simplified term, so it'd be easier for you to keep doing math. Like, say you had a bunch of these, like you would not want to be adding root 3s plus going on to many root 3s and carry that over when you're doing functions and stuff like that. You want simple, usually. So you want simple. You want simple answers, if I'm saying that correctly. You want simple answers. So, thank you so much for the time you have today, and please subscribe, post a comment down below, like the video if you want, and if you want even more simplified worksheets for yourself so you can master these kind of concepts with adding and subtracting, please make sure you log us on or hit us at our business email so you can get these kind of worksheets. Thank you so much and have a great day.